Hey there folks, today we're diving into the wet and wild world of underwater construction. Building underwater is a whole different animal. It comes with a unique set of challenges that would make even the toughest construction worker break a sweat. Water pressure adds a whole new level of difficulty to every task. Then there's the visibility issue. It's like trying to build a house in a blizzard, except the blizzard is made of water. And let's not forget about the currents. They can change in an instant, throwing your whole project out of whack. Despite these challenges, skilled engineers and construction crews manage to pull off some incredible feats underwater. Now, before you can even think about pouring concrete underwater, you need to create a dry working space. That's where our friend the Cofferdam comes in. Think of it as a giant temporary bathtub that holds back the water. Trying to build something solid while battling against the constant force of water is next to impossible. That's why we need to temporarily remove the water from the equation, and that's exactly what a cofferdam allows us to do. It creates a safe, dry environment for construction crews to work in, free from the relentless pressure and movement of the surrounding water. In the next section, we'll explore how these engineering marvels are built. Stay tuned. Building a cofferdam is like assembling a giant underwater fence. It starts with driving a series of guide piles into the seabed. These piles are like the corner posts of our fence. They provide a framework for the rest of the structure. Next come the sheet piles. These are long, interlocking sections of steel or concrete that slot into place between the guide piles. As the sheet piles are driven deeper into the seabed, they create a continuous wall that surrounds the construction area. The key here is to create a watertight seal. Any gaps or leaks will render the whole cofferdam useless. Driving those massive piles into the seabed is no walk in the park. It requires some serious force. That's where the pile-driving hammer machine comes into play. This beast of a machine uses a weight, or hammer, that's repeatedly dropped onto the top of the pile, driving it deeper and deeper into the earth. But here's the interesting part. Vibration plays a crucial role in this process. The hammer's impact doesn't just push the pile straight down, it also creates vibrations that travel through the pile and into the surrounding soil. By harnessing the power of vibration, pile-driving hammers can efficiently install the support structures needed for our cofferdam. Section 5. Barges and cone penetration tests, essential tools. Now, before we start hammering away, we need to make sure the seabed can actually support the weight of our cofferdam and the structure we're going to build inside it. That's where barges and cone penetration tests come in. Barges are flat-bottom boats that serve as floating platforms for construction equipment and materials. They're essential for transporting heavy machinery like pile-driving hammers to the construction site. But before the heavy lifting begins, we need to get a feel for what's going on beneath the surface. That's where cone penetration tests, or CPTs, come into the picture. This data helps engineers determine the strength and composition of the seabed. Section 6. Pumping out water. Not as simple as it sounds. Once our cofferdam is built, it's time for the big reveal, or rather, the big removal. We need to pump out all the water inside the cofferdam to create that dry working space we've been talking about. But remember, we're dealing with a lot of water and it's constantly trying to find its way back in. Engineers have to carefully calculate the pumping rate to avoid upsetting the delicate balance of pressure inside and outside the cofferdam. Pump too fast, and you risk collapsing the cofferdam walls inward. It's a delicate dance, requiring constant monitoring and adjustments to ensure a safe and successful dewatering process. Section 7. The cofferdam collapse risk. Speaking of collapsing cofferdams, let's talk about one of the biggest risks in underwater construction. When you remove the water from inside the cofferdam, you're essentially creating a vacuum. The water outside is still pushing inward with tremendous force, and if the cofferdam walls aren't strong enough, they can buckle or even collapse entirely. That's why engineers design cofferdams with this pressure difference in mind. They use robust materials, reinforce the walls, and often add internal bracing to withstand the external forces. Safety is paramount in any construction project, but it takes on a whole new level of importance when you're dealing with the immense power of water. Section 8. Bracing frames, keeping it all together. Imagine building a house of cards. To prevent our cofferdam from collapsing under the immense pressure of the surrounding water, we need to add some extra support, like bracing frames. These frames act like the internal skeleton of the cofferdam, providing additional strength and rigidity to the walls. They're typically made of steel or concrete and are strategically positioned within the cofferdam to distribute the load and prevent buckling. It's like adding internal walls and support beams to our house of cards, making it much more stable and resistant to external forces. Section 9. The concrete seal, a watertight barrier. Even with a strong and stable cofferdam, we still need to deal with the sneaky nature of water. It loves to find even the tiniest cracks and crevices, seeping in and jeopardizing our dry working environment. That's where the concrete seal course comes into play. This layer of concrete is poured at the base of the cofferdam, creating a watertight barrier between the inside and outside. It's like building a moat around our castle, keeping the enemy, water in this case, at bay. Section 10. Clamshells, vibrators, and Tremme's tools of the trade. With our cofferdam pumped dry and secure, we can finally start building the actual structure inside. But even with the water out of the picture, underwater construction requires specialized tools and techniques. Let's talk about clamshells, vibrators, and Tremme's. Just a few of the tools that make underwater construction possible. A clamshell bucket is a type of excavator bucket that's perfect for digging and excavating underwater. Vibrators are used to compact concrete underwater, ensuring a dense and strong final product. They vibrate the concrete mixture, removing air bubbles and helping it settle into a solid mass. Finally, Tremme pipes are used to pour concrete underwater without allowing water to mix with the concrete. Section 11. Pouring concrete underwater. A delicate dance. Pouring concrete underwater is a bit like trying to fold a fitted sheet in the dark. It takes practice, patience, and a bit of finesse. You can't just dump a truckload of concrete into the water and hope for the best. That's why the Tremme method is so essential. The Tremme pipe acts like a giant straw, delivering the concrete to the bottom of the excavation without allowing it to mix with the surrounding water. It's a delicate dance between concrete and water, but when done correctly, it results in a durable and long-lasting foundation for our underwater structure. Section 12. Building strong foundations, footing shafts, and rebar. In any construction project, the foundation is key. And when you're building underwater, the foundation needs to be extra strong to withstand the constant pressure and movement of the surrounding water. That's where footing shafts and rebar come into play. Footing shafts are essentially large concrete columns that transfer the weight of the structure down to the bedrock below the seabed. And just like you'd reinforce those table legs with metal brackets, we reinforce our footing shafts with rebar. Think of it as adding a steel skeleton to our concrete bones, making the entire structure incredibly strong and durable. Section 13. Taking down the cofferdam mission accomplished. With our underwater structure complete, it's time to bid farewell to our trusty cofferdam. But removing it is just as important as building it in the first place. Engineers will typically remove the cofferdam in stages, allowing the water to gradually equalize and minimizing the risk of damage. It's like carefully deflating a balloon, releasing the air slowly to prevent it from popping. Once the cofferdam is gone, we're left with a brand new bridge pier, tunnel section, or whatever amazing structure we were building underwater. It's a testament to the ingenuity and skill of the engineers and construction crews who make these incredible feats of engineering possible. Section 14. The allure of underwater construction. Well folks, there you have it. A glimpse into the challenging and rewarding world of underwater construction. It's a field that demands precision, ingenuity, and a healthy dose of courage. From the initial planning stages to the final removal of the cofferdam, every step is critical to the success of the project. But it's not just about overcoming technical challenges. There's a certain allure to working underwater, a sense of adventure and accomplishment that comes with building something in such a hostile and unforgiving environment. And who knows what the future holds? As technology continues to advance, we can only imagine the incredible underwater structures that will be built in the years to come.